Hello, I'm Jason, iOS developer at Uzu. Here I'm going to talk about several strategies to reduce UI-related bugs. This session consists of 3 parts. At first, UI bug itself will be discussed, and later I'll talk about how to reduce 2 different types of UI bugs. UI-related bugs are issues where there is mismatch between what user sees and the data underneath. Like in this diagram, on the screen promotion is applied, but corresponding flag in the memory has false value. Now we can think about several characteristics of UI bugs. It does not crash the app. Setting any text on UI label is fine, even if it is not what we intend. Also, it is hard to be assertive. How do we make sure if the image on UI image view is not cropped? Maybe we can think of snapshot testing, but the overhead coming with it is quite high in iOS development. Lastly, it is hard to be inspected without debugger. For example, how can it say if flag is also true on memory when UI switch is on without debugger attached? So what's the matter with these kind of UI-related bugs? As time goes by, data which iOS app should process is becoming more sensitive and critical. For example, banking apps collect amount and recipient to transfer money. Delivery apps recognize and store physical location of the device. Booking apps need date range and guest details for making reservation. UI-related bugs in these cases can cause user to lose trust, time, or even cash. UI-related bugs can be classified into 2 kinds. The first kind is view property bugs. These bugs are related to the properties of the view itself, like wrong constraint or hierarchy, preventing content to be rendered, or property values like font color or alpha, which make it invisible or hard to be distinguished from the background. There are several ways to reduce view property bugs. The first one is to using a design system. Usually design systems are tested to render content correctly in various environments. Also, it can reduce complexity in the code, assigning view properties, making it easier to spot issues in advance. Also, robust automated UI testing and quality assurance can help catch this kind of bugs too. The other kind is bugs caused by app logic. Let's think about the screen for placing an order. It has a text field for promotion code and label for amount due. The data representing them has also 2 fields for each of them. Now user has a promo code for applying 20% discount. The code was successfully applied, but the app logic somehow forgot to update the amount due, making mismatch between the value on the screen and data. This is a critical issue which can eventually cause user to abort the purchase. So how do we reduce app logic bugs? First, we need to analyze states the UI can be in. For instance, shopping cart screen has multiple elements, and each element has their own set of state. With these, we can construct a table with combination of them. In this table, first 2 cases are covered with specification and testing, but the latter 2 were not considered enough. Usually this is where the logic bugs are. The more combinations of state we cover, the lesser chance of logic bugs existing. The second strategy is to make user input. User input changes the data, and that mutated data triggers UI update. Let's think about the switch, toggling yes and no. This function updates UI and state at the same time on tapping no. As we can see, if validation fails, UI is updated to false, but the selected state stays same, true. To resolve this issue, as we saw in the previous slide, tap no function only update the state is selected, and changes of is selected update to view option view. The third strategy is to apply educate design pattern. Breaking down big component into smaller single responsibility components can dramatically improve readability and testability of the code. Also, design patterns like coordinator and view controller factory can improve encapsulating complex configuration from the color. For example, view controller factory can prevent duplicate code instantiating and constructing screen. Also, it makes it clearer about the required parameters. The last strategy is refresh more and often. If the calculation time for states are constant or even increased linearly, it is in some cases better to update the whole screen rather than some part of it. For example, the stereo view has different components of the screen as different sections. Rather than implement multiple functions updating part of the section, we can write one single function generating sections object from the same set of parameters, even if it's not changed. Benefit from this approach is that we can prevent bugs when two parameters or states are affecting each other subtly. To recap, there are 4 strategies to reduce UI-related bugs caused by app logic: analyze state, data drive UI, apply design pattern, refresh more and often. Thank you very much for your attention and have a good day.